hope everyone is fine wherever you are, and hope you are kind of getting time to learn things. And I hope you guys are looking for something new which you can learn today. So what we are trying to do today is there is a topic which is kind of a buzzing in the market, and a lot of companies are looking for professionals to enable the digital twin in the market. So we will try to learn what a digital twin is, and how can we get into that path of helping out the factories, helping out the industries, of getting their digital twin done. Okay, so let's move to the agenda today. Shruti, can you move to the agenda? Yeah, so the agenda of the day is that we are going to start with what a digital twin is. And if you know about a lot of you would have heard about Industry 4.0. Then we need to understand a bit of what Industry 4.0 is. That is where the digital twin is being fit into. Then how a phase of design, build, and operate can be made better with the concept called digital twin, and how to build a digital twin, and what are the applications of this digital twin, and what are the evolutions in the field now, and going forward, what roles you can look forward, and what are the companies that are hiring into this area of digital twin. So we will start our journey of understanding a bit on what these things are. Let's move forward, guys. So as you can see over here in the picture, there is on the left side there is a car. Okay, so that car is having which is in the real world, is pushing lot of data like in your it will be showing a fuel gauge, it will be showing the odometer reading, and all these things, right? So some advanced car will be having the tire pressure, and all these things, whatever the engine condition is, whether the engine is hot or cold or whatever. So there is basically no point of having all these data just in front of the driver. Okay, so if we have all these data together in one platform, for example, a mobile application, and we can see what is happening. See, for example, the engine heat is going high, the temperature is going high, or the vibration of that engine is beyond the limit. How can we get to know that, right? So these things can be pushed into a mobile application or a web portal, and then you can see over there the exact replica of what is on the ground. So the car, whatever data is being you are able to see in the odometer and all those gauges and the visuals that you see inside the car. If you are able to track everything, including the failure that can happen for that particular car in a mobile application, that is what a digital twin is. So in real terms, what we can call it, can you go back, please? So the real term of digital twin is the digital representation of a physical object. It might be a physical object, or might be a process or a service. So service means maybe it is something like or a supply chain problem. You are getting a shipment from Amazon. If you can track all the details in real, and you will get to know that, okay, this is gonna be late, or this is where it is, and this is the status of the product, and this item is being shipped at maybe -5 degrees Celsius Celsius, and all these data you can see, if you can see in your mobile, that is what a digital twin can be called. So it is basically a digital replica of the asset or a plant, or being a plant which is being designed, built, or being operated. So for example, the car that we just took, right, that is example of a asset being operated. So this is what a digital twin is. So we can go and understand a little more on the real concepts of digital twin a little better. So Shruti, can we go forward? Yeah. So as I already explained, so as you just saw in the previous picture, right? It is basically these are the things that enables a digital twin, or these are the points which are composed in a digital twin. First thing might be a 3D copy of a physical infrastructure or a service flow. For example, it might be just a 3D drawing that you designed in your PC of that particular thing. So for the example that we took is a car, right? So the exact replica of car we have in the system. So that is the 3D copy of physical infrastructure, the first point. The second point, the sensors. Whatever data, whatever the operating parameters of that particular car, for example, it might be the fuel status, it might be the temperature and vibration data of the engine. All these, how can we convert that into a what you call a digital format, right? So to get that into a digital format, you need to have the sensors first. Maybe it might be just a temperature sensor. The temperature sensor will be sensing what is the temperature, and it will be keep on monitoring what are the other parameters running. See, for example, a pressure gauge will be just checking the pressure of that particular flow in a tank or whatever. So these things. So first, we mentioned that there will be a 3D copy. Then on top of that, the asset will be carrying the sensors. Then these sensors will be pushing some analog data through a real-time data connectors. So these real-time data connectors pushes the sensor data to a cloud platform most of the time. So what is a cloud platform? The cloud platform is where all these things are being interconnected, because of which you can even see that in the mobile. So these sensor data will be connected to through the real-time data connectors, and that real-time data connectors will be pushing the data to the cloud platforms. Then what the cloud platforms do, right? So there will be a lot of historical data behind the cloud platform itself. See, for example, if you are using a bike for quite some time, maybe 5 years or 6 years, you will be already having a history of temperature and pressure and vibration of the engine because of all these things. Maybe because of the for example, if you hear a sound change in the engine, you will get to know that there is some problem gonna happen for the engine, because of which a failure will be triggered. So that kind of things, right, that history will be stored in the cloud platform, which is in a historical data repository. So the historical data repository will be carrying all these information of what has happened before, and what are the temperature or pressure or a vibration data which happened at that point of time of failure. So all these things will be in the cloud platform, and there will be an analytics engine running. So what is an analytics engine, right? So we have the history and all these things behind us to support. So we have to keep on monitoring what is the real-time data which is coming, what is the temperature which is coming. See, the temperature is going beyond maybe 200 degrees Celsius. We get to know that, okay, there is a problem. So analytics will be running. So analytics is like a calculation machine which keep on checking what is the data now, and whether that is a failure which is going to happen, or it is okay, or it is normalish. So that is what analytics calculation engine which is doing behind. So there are a lot of predictive algorithms which is being built by the computer guys who will be setting this up. So what is the role of mechanical engineers or electrical engineers over here, right? Or the instrumentation engineers for that matter. When you can see here the sensors, then the real-time data connectors, then the analytics. So analytics, who tells the computer engineer that this is the analytics that we need to run, or this is the calculation that we need to run, or this is the way of failure which is gonna happen. So this is where the mechanical engineers or the instrumentation engineers or the electrical engineers or the easy guys comes into picture. So I believe you guys would have got a picture of what you guys can contribute on a digital twin, right? So because this is a very important thing, because we start from the 3D copy, then the sensors and all these pieces which is clubbed together, and we create a digital twin that you can see in the cloud, which is being in the PPT, right? So the physical asset is on the right side, and we convert that into a cloud, which is a real representation of what is happening on the ground. So it carries the operational history, the maintenance history, then the CAD model and everything. So so let's see what a digital twin is in the market, right? So yeah, you can expand that.
Digital twins, innovation backbone of the future, delivering virtual representations of real-world products, systems, and cities. For example, the digital twin of an electric motor not only showcases form, but also analyzes functions, from the rotation of the shaft to thermal conductivity to data from sensors and beyond. What's more, the digital twin continuously evolves, thanks to the flow of data, user experience feedback, and new input, and it's greatly impacting development, production, and operation. In development, a product's behavior can be simulated and tested long before a physical prototype has been built. Siemens utilized the digital twin to develop a world record-setting electric aircraft motor that not only weighs 50 kilograms, but is also 5 times more powerful than comparable electric motors. But it doesn't stop there. Digital twins also unleash the power of 3D printing. In a recent Siemens study for gas mixing systems, insights from the simulation of form and flow behavior were combined with generative algorithms. The result? A truly unique channel shape and configuration, one significantly more efficient than anything previously designed. Even entire factories down to individual machines can be simulated and tested. For instance, robots. It's difficult for them to perform milling tasks because large forces in the manufacturing process lead to inaccurate movements. But with the digital twin, the forces that push the robot away from the milling path can be calculated and compensated in real time, keeping the robot in its path. When it comes to operations, digital twins can compare the sensor data of a real point in real time with the simulation of its point. The availability of the point parallel to operations can be reliably predicted, and sudden disruptions become a thing of the past. But this is just the beginning, and Siemens is already driving the future. Merging digital twins with artificial intelligence allows computers to independently design advanced products. Siemens is realizing this potential right now with Californian startup Hackrod, which aims to build customized sports cars. For development, production, and operation, the digital twin breaks with traditional paradigms and opens up extraordinary possibilities. That's why digital twins are the innovation backbone of the future.
Siemens, ingenuity for...
I believe you would have got the crux of what a digital twin is by now, because we have gone through how we can build a digital twin, and what a digital twin is, and what are the benefits of digital twin, right? So let's move forward, and you can see that companies like Siemens, GE, and all the players in the market are looking forward to that. And people like you need to invest time to understand this in detail, and you can trigger this thing, because there are not that many people in the market who can help them out. So yeah, let's move forward, Shruti. No,
Digital twins.
go next, maybe. Yep. So let's see. You can see the fourth stage, right? So the fourth stage on the right end, which is cyber physical system. That is what we are in now, which is the Industry 4.0. So what Industry 4.0 is, and what a digital twin has to do with the Industry 4.0, I will just explain. If you can see in the first stage of industry revolution, right? So it was more of a mechanization, something like a steam power, weaving loom. All these was happening in the period of 1780s. So 1780s. So that was the point of industry 1.0. Then comes the mass production, which is called the industry 2.0. These things were happening in the 1870s. Then comes the third phase where automation comes into the picture. So what automation was doing is the repetitive process with the help of computers and electronic chips and all these things help to produce more in a more precise manner and with less defects. So that was the phase of third industry, industry 3.0. So third phase of industry revolution. So next phase where we are in now today is the industry 4.0. Industry 4.0, what an industry 4.0 is that we already built the automation, then we had the computers, everything, but we were not connecting all these things that we developed, the equipments, then all these pieces, the information, because we were missing that piece of internet. So when the internet and network thrived in after 2000, what happened was we got that extra capability to connect all these things and keep on analyzing what is happening and what was the history of that particular asset and what can be the future. So that is what we are mentioning industry 4.0, which is the cyber physical systems. So digital twin is the main one of the main pillar of industry 4.0, which helps the internet of things. If you don't have the sensors connected, the data were coming from these equipments since quite some time, but if you know, there is something called SCADA, which users can the equipment operators can just see, but they have to take the action what need to be done. But in the cyber physical system of industry 4.0, you will be told what is the action and how we can take that. So this is the place where the digital twin fits into the picture. So yeah, let's move forward, Shruti. So this is the history of the term digital twin. So the concept was actually first introduced by David Gelmeter in 1991 in his book called Mirror Worlds. So it was embraced by NASA. So this was there for quite some time, but it was not embraced in the industry at all. So this was embraced by NASA in 2010, and the coining of the term also happened at that point of time. So you can see that in 2010, which means it's just 11 years behind, right? So that is the progress that has happened in this industry actually. So NASA adopted it to create a digital simulation of space capsules and craft for testing the model. So what happens is that the whatever NASA is creating, the spaceships and all, right? So this is This is quite on the safety part as well as on the monetary side. If something is broken or something happened, the failure is very, very costly at that point of side, right? So what happens is that the NASA kind of people keep on looking for the advanced solution on how they can decrease the cost and how they can be saved from the failures. So NASA adopted this concept and they started building the digital simulations. So, and if you can, you see that there is a company called Gartner in the industry circle, which is kind of famous. Uh, they they mentioned in their books. They mentioned in recently that uh, uh, the digital twin is one of the buzzing thing in the market, and that is what all the industries are going forward to. So this is a little bit about the history, so that you can understand what is a digital twin, and what is the history of the term, and how nascent the stage is the digital twin, right? So yeah, let's move forward, Shruti. Yeah, so let's you might be knowing the cycle of asset, right? Or a cycle of a factory, or whatever equipment you are having. See, for example, you are having a bike. That bike came from a design phase and someone built it and you guys are operating it, right? So you guys are using it, you people are using it. So this is the whole cycle of an asset in the terms of, maybe it might be a laptop, might be a mobile, might be your bike. The similar is the case of the factory as well. The factory also starts with designing the factory first, then building it with the assets or the equipments which are in the factory. Then the operations and maintenance people start using it and use it to the maximum, so that the companies, the organization get profit out of it, right? So let's move to the let's understand how the digital twin can help the design side of the picture, right? So let's move forward, Shruti. Yeah, so design, right? So in the design phase, you know that there is what a digital twin can help, right? Here, the first thing is that you might already got the crux, saying that, okay, the first of all, what the first thing that we need to do is you have to create the solution virtually. Which means whatever, we just saw the case of spaceship, for example. Spaceship, when you design it, what was the practice before was you just design it, but you don't test it, right? But with the historical data or whatever available failure history and all those things, whatever was done before was there might be a AutoCAD or a Bentley's CAD model or something like that, and people will be just designing it, feeling that this is gonna be a success. Maybe they will be doing the stress analysis and all these things, but not in the real terms. What they do is they design it, then they create a prototype of it, then they test it. So now now it is a different phase altogether. What is being done now is that they design it virtually, and when they design it, they can test it. They can kind of test it with the historical data for the similar assets, and they can visualize the performance of how the asset is gonna behave, how the spaceship is gonna behave if this kind of temperature, or it is going out of this going to the space, then this is the kind of pressure and temperature scenarios which is going to come into the picture. So people can visualize it in the design phase itself, other than the prototyping phase of it. So this is where digital twin helps in the design phase of it. Let's move and see what is being done on the build side of it, and how digital twin helps in the build phase. So in the build phase, what is happening? There will be for example, there is a construction of factory going on. So over there, you have a lot of things. So you don't need what is the stage of the current progress of that particular factory. So all these things can be done via monitoring the progress and all these things through a reality modeling. What is the stage now, and it will be extrapolated to whatever is existing in the present planning structure, right? So even the procurement streamlining, then commissioning and smooth handover. So all these phases in the build phase of of developing a factory or an asset, digital twin can come into picture. So shall we move forward?